Hey guys, Will here. So in my recent channel update, I let you guys know that I was going to be building a new desktop PC and told you guys a little bit about the history of some of the stuff that I've done before. I actually used to hold a couple of world records for overclocking and things like that, and PC building and stuff like this has sort of always been an interest of mine. It's something that I sort of come in and out of occasionally, but I thought that it's time to build a new desktop PC, so I thought I'd go all out and do a crazy build. This machine is going to be used for all my video editing. It's also my 24/7 driver for work as well, so it's really a work computer. I'll be doing a little bit of gaming on it as well when time permits, but primarily it's going to be a work use computer for things like video editing and stuff like that. But we're going to go all out with this build, so I thought it'd be a really cool idea to share everything with you guys on the channel as well as we go. Now there's a lot of things like unboxing videos and time-lapse videos of crazy water cooling builds and stuff like that, but what I want to do with this is really sort of cover every aspect of what I'm doing in detail so that people can follow along and people can get ideas for their own. So what I'm going to do in this video is take you basically through what all the components are of the build, and then we'll talk a little bit about how it's all going to kind of come together. And then what I'll do is I'll split it up into a couple more videos. We'll do a couple of unboxings of a few of the key components, and then I'll also, show you how I'm going to modify the case. I've got a bunch of stuff to do there, but and look, anyway, let's get stuck into the video. I'll start by showing you through some of the components. So we've got the Fantex case here, which it's a really nice looking case, and I'll take you through the details of that a little bit later on. But the reason I chose this case is it's really nice and accessible. It's great for water cooling, but it's still relatively small as well. It's not a massive tower case. I used to have a full tower previously to this, and it was up here kind of thing, and it was just massive. But this should do everything that I need in a relatively compact package, and I've already taken the sides off it. They're glass, they're sort of tinted glass panels on the side, and so I've taken them off so they don't get damaged. Now I've also got this Perspex sheet here as well, which I'm going to be cutting up with a Dremel and using to build a new plate on the bottom of the case as well to run some water cooling gear and stuff like that, but I'll cover that in a little bit more detail later. So the key components are a Corsair AX860 power supply, so really high quality power supply there. The previous build that I did, I used a 1500 watt power supply, and I think it was a little bit overkill. I'm only running a single graphics card in this build, so I'm not going to go crazy with the power supply. I want to try and keep it as efficient as possible, and I think 860 watts should be a pretty good mark there. So the AX series is nice and stable, really good quality power rails that should hold nice clean voltages all the time for overclocking and stuff like that. So I'm hoping that will do the goods. ASUS, so we'll move that out of the way actually as we go. So we've got an ASUS ROG Maximus X Code motherboard. So I spent a lot of time researching motherboards, and it's not like it used to be with motherboards. Every motherboard used to be sort of kind of the same, and you'd have to solder things onto the motherboard to overclock and stuff like that. And these days, motherboards are pretty much designed for overclocking. Now, the reason I chose this one is it's got really high quality VRMs on it, which should make it really good for overclocking. Basically, the way that works is the more stable the VRM, the more stable the voltage. When you have large spikes in current for a CPU power draw and stuff like that, what happens is the voltage can droop a little bit, and when that happens, you get instability. So this should hold nice stable voltages for the CPU and all the different various rails for RAM and graphics card and stuff like that as well. So really excited to test this out. Another feature that I was excited about with this board as well is the fact that it has BIOS flashback as well. So if you have a problem with a BIOS flash, you can always roll it back to the other BIOS chip and then recover it. So I do tend to dabble a little bit in custom firmware and tweaking things like that as well. So I wanted something that was going to be nice and stable and recoverable if I do screw something up. So that's the motherboard, and I probably will do an unboxing video of that simply because it is a pretty exciting piece of kit there. Next component we'll look at is the Core i7-8700K. So this is the latest 8th gen i7 chip. Now I toyed around with the idea of going with an i9, and I kind of thought, well, look, for the majority of the work that I'm going to be doing, the software isn't going to utilize the multiple core advantage of an i9 processor. Also with the Threadripper series from AMD as well, it just didn't seem like it was going to be value for money for me. So I decided the 8700K was going to be the best bet for me. It should be nice and overclockable. I should be able to hit about 5 gigahertz pretty easily on this chip. And what I found is for gaming and for a lot of video editing software, a good clock speed per core is more important than having lots of cores, because the software a lot of the time doesn't really utilize the multiple cores properly anyway. So I think this is probably going to be the right chip for that. Now, you can see the chip there. A lot of people do what's called de-lidding on these chips, where you actually take the lid off the CPU, replace the thermal compound underneath, and then put it back on. I'm not going to do that to start with this chip, because I want to see how it performs out of the box. If we do find that we're having temperature issues with it, I'll pull it out again and de-lid it later on. So we'll set that aside. Now, this is where things started to get a little bit crazy. This is a 2 terabyte 960 Pro M2 SSD. And this thing was about, I was thinking it was a little bit over $1,500. So really, really expensive. And I didn't want to skimp on storage with this machine, because with copying large files and editing large video files, access to those files is extremely important. So you can have the fastest PC in the world, but if you've got slow storage, the overall user experience is going to be slow. And I think this is the thing that a lot of people overlook the most when they're doing a PC build. They think, I need a fast CPU, I need lots of RAM, I need fast RAM, but they don't think about their storage speed. And you know, because you're accessing files in day-to-day use all the time, the speed that you can access and read and write those files is probably the most important thing for day-to-day PC use. So I really didn't want to skimp with that. So I got a massive 2 terabyte one as well, because I don't want to have to deal with things like scratch disks. I don't want to have to copy files across onto another drive all the time. So I thought this was going to be the best bet, and I was happy to spend a bit more money in this area. So we'll set that guy aside as well. Next up, we have our RAM. So I've gone with 32 gigabytes of DDR4 3200 megahertz, I think it was. Yeah, 3200 megahertz CAS16 RAM. So when you look at RAM, there's a lot of different frequencies that you can buy and a lot of different CAS latencies as well. The way it works is the latency and frequency ultimately determine how fast the read and write speed is of the RAM. So there's a sweet spot there where, you know, you can go higher frequency but higher CAS as well. And what happens is the overall speed of the RAM ends up being the same. So the best compromise for me with this build and what was compatible with my motherboard was 3200 megahertz at CAS16, and I'm going to cover that in a lot more detail when we put the machine together as well. So we'll set that one aside. Next, we'll look at the graphics card. So if you guys don't know, graphics cards are stupidly expensive at the moment because of crypto mining. You've probably seen those crypto mining rigs where people string hundreds of graphics cards together to get better processing speeds. So graphics cards are crazy expensive at the moment. This was about $1,500, which, you know, is way more than I wanted to spend, but at the same time I did want to get a decent graphics card. So what I did do was compromise and only get a single card. I didn't want to go with SLI in this case, because the performance with SLI doesn't really scale all that well. I find with most games and most programs these days, it's about a 30% performance increase per card that you add. So say 100% performance with one card, then you add a second card, you only get about a 30% performance increase when you average it out across a lot of different platforms. So, you know, some games you might get an 80% increase, some it might be no increase at all, and some games it can even actually make the performance worse. So I thought I'll go with a single card for this setup. That also makes the water cooling loop a little more simple to put together, as well as less demand and less power consumption as well. So because this machine is going to be running all the time pretty much, I do want to try and keep it as power friendly as possible. So that is the graphics card. Now obviously we're going to have a water block for this as well, which I'll show you in a moment. So I'll set that aside. What can we look at next? We might actually, we'll look at the fans. So I've got some 120 mil magnetic levitation fans, which should be nice and quiet. So those are going to go on the front radiator. And then I've also got a combo pack of the same fans again, but in a RGB setup. So these actually have colored LEDs in them. And the colored LEDs are all driven from the motherboard as well. So you can have different effects going on throughout the case. And we'll talk about that more when we put everything together as well. But the whole thing is going to be RGB themed. So these are 120 mil fans. These are the ones that are going to go on the top radiator. And I'll show you the radiators in a moment as well. Set those aside. Now we've also got a cable mod pack here as well. Whoops. Set that back aside there. So this is nice. I'll just quickly open this up and show you actually. This is the cables that will run from the power supply itself up to the various areas inside the motherboard. So I'll just quickly undo this. And so you can see there, I won't unwrap them all, but really nice, clean, white braided cables, which will make a big difference to the look of the build. So we'll unbox those a little bit later on as well properly and take you through those. Set that aside for now as well. What else have we got is, oh, this is the one that's triggering everyone. I actually had to buy a genuine copy of Windows 10 Pro. Now this is stupidly expensive. It's about $250 Australian, and I know that you can buy license keys online for 15 bucks. For tax purposes, because this is a work machine primarily, I did need to have a physical copy, that's something tangible that I could claim back. We've got up here vertical GPU mount. So this case doesn't support vertical GPU mounting from factory, so there's going to be a little bit of modification involved in getting this to work as well, and I'll show you obviously how I do that with the Dremel and cutting and everything as we go. So that's going to be a cool little video there. So we'll set that aside. And there's a couple of other little bits and pieces here as well. There's a Fantex RGB LED strip as well, a couple of those to give us some additional LED lighting inside the case as well. A couple of other little bits and pieces up here. So we've got our RGB connection cable for the case lighting as well. So the little light at the front and the power button surround as well, I think. So that allows us to interface with the motherboard. The LEDs for the CPU water block as well, which are UV. A little tube of Arctic Silver 5 thermal compound. Now that hasn't changed in the last, I think, probably 10-15 years almost. Been using the same stuff for every build that I've done, and it always performs well. A couple of little reservoir blocks there as well to hold the water reservoir. And another adapter to mount the water pump. We've got a hardline tube bending kit here as well. Now I'm using hard lines in this build, so it should be a really, really nice clean looking build with those. And obviously again, I'll show you how I do all that as we go. So this tube bending kit has, mandrel bends. It's got the silicone insert that you use to actually bend the pipe without it crushing. A pipe cutting tool as well, and a chamfer as well to get the right beveled edge on the pipes as well. So hard tubing, I bought plenty of that because I'm assuming that I'm going to screw up a lot and have to redo things. I'll probably change my mind a couple of times with layout as well. Then we've got all of our water fittings. So all of our fittings that actually mount the pipes themselves. I think I've bought about 20 of those. We've got our little barbs there for our drain. So I've got a little tap there for the drain and a barb so I can connect a piece of pipe to drain the system out. We've got a couple of pass-throughs as well. These are all EK branded parts. So a couple of pass-throughs for the Perspex bottom plate as well, so I can run the pipe or run the pump down underneath the thing, and I'll show you that in a bit more detail in a moment. And just a whole bunch of other bits and pieces for fittings, and obviously we'll be going through all of that as we build it. Now we'll move on to the water cooling stuff. So this is where it starts to get really complex because, I spent hours and hours and hours trying to sort of plan all of this out, and because I didn't have any of the parts in front of me, it's very hard to sort of visualize how it's all going to go together. But we've got a Revo D5 PWM water pump. So PWM means that it's pulse width modulated, so it can be the speed of the pump can actually be controlled from the motherboard, so you can have it vary depending on temperatures or CPU load and stuff like that. So that will be nice and handy. We've got an EK Supremacy Evo water block for the CPU, and I'll be showing you all of these in detail and unboxing them as we go as well. And we've got a EK X3 250mm RGB reservoir as well. I actually probably will unbox this one in this video and just show you roughly how that's going to sit inside the case. We've got our back plate and front plate for the graphics card. So these are the water blocks for the graphics card. And we have our 240mm radiator, which is probably going to end up being the top radiator. And then our 360mm triple radiator for the front of the case. So that will sit in behind there. And what else have we got? That is pretty much it. There's a couple of bottles of coolant there as well, which we'll obviously need. And then we've also revealed through this the 38-inch Dell widescreen or ultra widescreen monitor as well, which I've already taken that out of the box. I've been using that on my laptop for the last couple of weeks, just getting used to it. And I'll give you guys a full review of that monitor a little bit later on once I've had a chance to play around with it with the new machine and see how it goes for gaming and stuff like that. But what I thought I'd do quickly now is just give you a quick look at the case and how all that's going to work. So I'll quickly cut, move things around a little bit. We'll come back and I'll show you how it's all going to kind of fit together. Okay, so basically the idea of the basic layout of the system is going to be a 360mm radiator at the front with 320mm fans, and then a 240 on the top with 220mm fans. Now there is this panel which removes out here, and obviously we'll see that in more detail when we pull everything apart, but if you have a large radiator at the top and a large radiator here, you don't have much of a gap in between here, and it also makes accessing the top of the case here very difficult. So what I decided to do was put a 240mm in the top here, 360 there, and that allows me to access the top of the reservoir. This top panel of the case actually pulls off. So what we'll be doing is mounting the reservoir. I'll just quickly pull it out of the box for you now, roughly here. Okay, so I need to be able to access the top of it for the fill port. So that's where I'll be filling up the case. So you want to be filling into the top of the system. So if I have this blocked off by a radiator, it just makes everything more difficult. So I thought I'll put a 240 here, have the 360 here, and then that gives me lots of space to mount this. So the tube for that will then run down out of the reservoir into the pump, and the pump will actually sit down below this panel. So let me just quickly move this reservoir back out of the way. So this metal panel here removes and allows access to this bottom area here. So we'll run a tube out of the bottom of the reservoir into the pump, which will be below this panel. So the pump, basically the input goes in the top here, and then the output comes out the front. So the pump will sit down in here like that. The water will go in the top, and then it'll pump out. So a lot of that sort of hardware will be hidden. The fill port is also going to be mounted down underneath here as well at the back of the case. So if we spin the case around, you can see there's a lot of access here. So we'll probably remove these drive bays altogether, sit the pump down here, and then I can run a tube with a splitter. So the splitter will sit down in here, and then we'll have our little drain port sitting down here, and I can just run a tube off to drain the system. Obviously the drain needs to be at the absolute bottom of the case, otherwise you're going to have problems. So spinning it back around again quickly. There we go. So what I'm going to be doing with the Perspex sheet that I showed you before is creating a new bottom panel here that will hide all of this stuff. So it'll kind of loop around here, curve down, and then I'm going to put a couple of pass-through ports for the water cooling lines inside that. So they just look like that. And so this area will be all blocked off. I'll cut the Perspex so it fits exactly around the radiator as well. So you'll see the pipe go through between the reservoir and the pump, and then another pipe come up for the line to come out and into the graphics card. So what I'm planning on doing is having the water come out of the pump up through into the graphics card, up through the graphics card, probably into the CPU, up into the top radiator, and then down into the bottom radiator. So what I'll probably end up doing is trying to have the ports for this radiator at the bottom of the case. The reason for that is it makes draining the system a lot easier. Obviously, if you've got the ports at the top for the radiator, when you drain the system, you're going to have to turn the system upside down and sideways to drain all the coolant out of that radiator. So if I can, I'm going to try and make those ports sit at the bottom of the case. If not, we'll have to do it at the top. It will make the routing of the pipes a lot easier if it sits at the top, because we'll just be able to run a simple line between here and here, and it'll be a lot easier. I want to try and sort of have a nice clean layout so the pipe will sort of come up. Remember, we're also going to have that vertical GPU as well, so the pipe should hopefully come out of the case, across into the GPU, go up into the CPU, out of the CPU, up into the radiator, out of the radiator again, down into the second radiator, back up and into the pump again, or into the reservoir rather. So I'm still sort of playing around with all that layout and trying to figure out exactly how I'm going to work all that, but that is the basic idea of the layout anyway. Alright, so that gives you a basic idea of what this system's going to look like and how it's all going to be laid out. Now obviously there's going to be a lot of work in this. I'm going to take my time, do it all right. We're going to be doing some modification at the back here. We're going to be making some custom panels. We're going to lay everything out very carefully. I'm going to be mounting water blocks on CPUs, taking covers and taking heat sinks off GPUs and putting water blocks on those. So there's a lot of work to do, and I really want to cover this in a lot of detail. So I don't want to just sort of do skimming over videos where it's just a time lapse and you don't really learn anything. I really want this to be something that you guys can experience and learn and follow along for the journey with me. So if this is something that you're interested in, I really would love it if you would like this video, and of course subscribe to the channel and hit the notification button so you don't miss out. Lots of cool videos coming up on this build, so stick around. Thank you very much for watching, and I will see you soon. Bye.